So we've got question 15 here, and this is quite possibly one of the most bizarre questions I've seen. So we've got a toy cheese. Yes, you've heard that right, a toy cheese. I didn't know they were a thing. And it's split into 3 parts. We've got part A, B, and C, where part A is a show that question to prove that the surface area is that equation below. So let's begin. So we are told that the volume is 240. So what we can do is I'll take my pen. We already know the volume, that's 240. So how do we find the volume of this shape? Well, what we can do is we can take the area of ACB and multiply it by H. And that would give us the volume of our shape. So how do we go about finding this first bit, the area of ACB? So what we need to do is we need to use an equation. And you know from radians that the area of this sector here would be a half r squared theta. So it's in your equations that you need to know for A-level maths, so please learn it. And essentially we just need to plug in those values. So we know that the area of segment ACB is equal to a half times r squared. We don't know the radius, so we're just going to say r. And then times 0.8. Quickly tidying that up, we get 0.4 r squared for the area of segment ABC. And then if we multiply it by H, we get that the volume is equal to 0.4 r squared H. Okay, and I've also written down here that the volume is equal to 240 because it is given in the question. So we can replace V with 240. So what we can do now is we can rearrange the equation to get H on its own. So I'm going to quickly do that. So we need to divide both sides by 0.4 r squared. And you would get this here, H equals 600 over r squared. Okay, so that's the first part of question A sorted. And now that we've got H in terms of R, what we can actually do is now find the surface area of this shape. So how would we go about finding the surface area? So what we can do, as you can see here, we've got 2 rectangles. We've got rectangle ACDF, and we've also got rectangle ABDE. So how would you go about finding the area of the rectangles? I'm just going to quickly draw myself a rectangle there. So what you need to do is quite simply base times height. That's how you find an area of a rectangle. We know that the base is R and the height is H, so that would give us RH. And because there are 2 rectangles, you need to times this by 2, giving you 2RH. Okay, so moving on to the next part. What we have here is our curved segment DEF, and we also have ABC to worry about. So how would we find the area of those 2 segments? Luckily enough, we've already worked that one out. So we can say that the segment, the area of the segment, is equal to 0.4 r squared. And because there's 2 of them, we do need to multiply it by 2, giving us 0.8 r squared. So for the final bit, we need to find this bit here, this curved region CBEF. Now, we know an equation that we can use. I'm just going to draw the shape here in a very scuffed way. But yeah, we can use this equation, L equals R theta. And we know that L is equal to, so R we don't really know, and theta is 0.8. This equation is in the formula booklet for A-level math, so make sure you do know that one. Okay, so after that you've found that side, so L here is equal to side either CB or EF. So we've got side CB/EF, but in order to find the area of the total shape, what we need to do is take our length, 0.8 r, and we need to multiply it by h. There we go. Okay, so now we've got three equations for our areas of these shapes. So what we need to do now is put it all together. After that, we can substitute this here into our h variable so that our surface area equation is all in terms of r. So let's quickly do that. Okay, so I've quickly done that. And if you've substituted this in for h, you should get this equation here. Okay, and all we need to do now is simplify. So we've got the r on the top here, and then we've got an r squared term on the bottom. So we're going to lose an r on the top and the bottom. So we have 2 times 600, which is 1200. And then we lose an r on the top and the bottom to get 1200 over r. The next bit is just normal, so we keep, so it's fine. And then looking at the next bit, 0.8 times 600 is 480. And then we have this common factor of r, so it'd be 480 over r. And then we can essentially add these two terms together, and that will give us 1680 over r, add 0.8 r squared. Okay, so question B essentially tells us to find the value of r for which s is stationary. Okay, so what we know about stationary points is that if we differentiate the equation and we set the derivative to 0, we will find r, which will give us the value of r for which s is stationary. So let's quickly differentiate the equation. So we'll get ds by dr. That will give us 1.6 r minus 1680 r to the power of minus 2. Okay, so it wanted us to find the value of r for which s is stationary. So as I said, we replace this ds by dr with 0 to find the r point. And now all we need to do is rearrange the equation. So what we can do is times everything by r squared to get rid of this term here. So what we'll get is 0 is equal to 1.6 r cubed minus 1680. And then we can rearrange the equation to get 1680 is equal to 1.6 r cubed. And if we divide both sides by 1.6, we'll get 1050 equals r cubed. We will get r is 10.16396 blah 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 blah, which is approximately equal to 10.2 to 1 decimal place. Okay, so for the final question, it says prove by further differentiation that r is the minimum surface area. So how would we find the minimum? That's our keyword, minimum. So in order to do this, what we do is we differentiate the equation twice, and the condition for a minimum is that the second derivative, I'll just say S prime prime for short, would be greater than 0 to be a minimum. And if the second derivative is greater than 0, we have a minimum point. So that's our key bit of information that we need. So let's differentiate this twice. So we've differentiated this before, and I'm going to cut ahead for when we've done the first derivative. So I'm just differentiating the equation again, and this is the second derivative. So what we know from the previous question is that r is approximately equal to 10.2. And if we were to come back over here, if the second derivative is greater than 0, then we know that r is then minimum. So what we'll do is just substitute r, this 10.2, in for r. So we'll get 1.6 plus 3,360 multiplied by 10.2 to the power of minus 3. And if this is greater than 0, we have a minimum point. And quite simply, you can use your calculator for this. S prime prime is equal to 4.7662, so on and so on. Therefore, we can say that S prime prime is greater than 0 when r is equal to 10.2, so r is a minimum point. And that is our answer. That's all for today. If you like the video, please give it a like, and I'll see you all later.